Now, in this last section for this class, we are going to be looking at quantum numbers. And what quantum numbers are they are a series of symbols that help us easily talk to each other about information about an atom. It's like a football game ticket. You know how on a football game ticket, you'll have the gate, then the section, then the row, and then the seat. So for us, this is an atom, and you'll have the basically energy level is like the gate. So this is like the second energy level. That's the first energy level. So energy level, this is like the gate. And then it'll say, are you in an S, P, D, or F orbital? Some of them, like the second energy level, only allows S's and P's. It's not big enough for everything else. And so that's like saying the section. Which section are you in? Are you in the P section or the S section? Are you in the spherical shape? Or are you in the, like the going back and forth P shape? That looks a little messy. And then the row, so where you're going to go, the row is the quantum number. And what that's talking about is if you have like a p orbital where you have like a choice of being on the x-axis or the z-axis or the y-axis, it's which of those you're in. That's the row. And then last, the seat. So in atoms, you can actually fit 2 electrons per seat, which probably seems odd as thinking about a football game seat, but that's what it is. You can fit 2 electrons per seat, and it's which electron are you talking about. We represent electrons in seats in more than one way. Sometimes we represent a seat as being a square, and we will have an up arrow and a down arrow. That's a full arrow like that. You also might see a half up arrow and a half down arrow. You also might just see a line with an up arrow and a down arrow or full arrows. All of those are a seat in the orbital. So the primitive quantum number, obviously, it can be 1, 2, 3, 4. This is the shell. That's one word. It's the general region for the energy that electron has, the energy level. It's got a few different words, but that is the N value. Then we have this subshell, and this is a shape of the orbital. And I mentioned this a little bit ago, but there are nodes, just so you know, nodes. The electrons are not in the nodes. So this section isn't as helpful of information. Don't overly worry about that section. But if you're in the N equals 1, it only fits 2 electrons. It only has S's. If you're in the N equals 2, though, you can have S's and P's. If you're in the N equals 3, you can have S's, P's, and D's. And then 4, you can also have F's. I don't know why we didn't just go ahead and say SPDF, but we didn't. Instead, we started using numbers to represent these letters that are represented by shapes. I didn't design it. So an S is a 0. Think of a sphere. That's how I remember S is 0. It's like a sphere, 0, kind of looks the same. P is 1, D is 2, F is 3. So for example, this S, its azimuthal or angular quantum number or L value would be 0. All S's are 0. All P's are 1. All D's are 2. Now you'll notice that with this numbering system, these are the only 2 possibilities that will fit in a second energy level. Notice that they are both 1 level less than 2. Like it's 0 and 1. They're at least 1, if not more than 1. And again, here, look, see, that's a 0, which is less than 1. That's kind of what they're getting at. And here with the 3, so 2, 1, 0. The L numerical value is always 1 less or more than 1 less than the energy level. And if you have something that's degenerate, so this is really more for the degenerate stuff. It won't matter as much for the S stuff, but for the degenerate stuff, like we were talking about how you could have a p orbital in that direction or kind of like coming out at you of the board. So to decide which one, remember we called the P a 1. So we might label that as 1, that as 0, and that as -1. And then lastly, within one of those orbitals, they could be like that. They could both be in the same section, but which electron are you talking about? Are you the up electron or the down electron? We use a numerical value of 1/2 or -1/2. So let's pull this all together. If I'm talking about an electron in the second energy level, I would write a 2 down. If I'm talking about a p electron, I would then write a 1 down. So this is energy. This is the shape. Then I would have to say which one I'm talking about. Now you would pick, let's just say that it's the middle one, the 0 one. And then I just have to recognize that I could either put an up electron or a down electron. It would either be a negative 1/2 or a positive 1/2. This is a little wishy-washy right here because some people like the negative 1/2 to represent the up electron. Some like it to represent the down electron. I've seen it both ways. The point is, in this last position, just make sure you put a 1/2 of some sort. And why is it 1/2? This video explains the spinning of electrons and why we call it 1/2. That's beyond what you have to understand in chemistry, but if you want to know, it's a good video for you.